Good day everyone, my name is Jeremy Vasquez, CHEM16 section CIJ2. For today's video, we will discuss about wave of nature matter, quantum numbers, and quantum mechanics. So, let's start. Wave of nature matter is all about particles with their mass like proton or having mass like electrons. Wave of nature matter is also a central part of theory of quantum mechanics, being an example of wave-particle duality. All matter exhibits wave-like behavior. For example, a beam of light or a water wave. This is the de Broglie wavelength. Why is the de Broglie wavelength? H is the Planck's constant, m is the mass of particles, v is the speed of particles. Y is equal to h divided by p equals h divided by mv. I have an example here using the formula. Here. H is equal to 6.626 times 10 to the power of negative 34. M is 9.1 times 10 to the power of 31. And V is equal to 2 times 10, 6 ms1. So, 6.626 times 10 to the power of 34 divided by 2 times 10⁶ ms1 times 9.9 times 10 to the power of 31. So, here's the result. Y is equal to 0.364 36 times 10, 109 m. So that's all for wave of nature matter. So let's proceed to quantum mechanics. Quantum mechanics is the behavior of very small particles like atom, molecules, and subatomic particles. Quantum mechanics explains all how the universe works at the scale of smaller atoms. Quantum mechanics is a fundamental theory in physics that provides a description of the physical properties of nature of the scale of atoms and subatomic particles. It is a foundation of all quantum physics, including quantum chemistry, quantum field theory, quantum technology, and quantum information science. Who invented quantum mechanics? Niels Bohr and Max Planck, two of the founding fathers of quantum theory, each received a Nobel Prize in Physics for their work on quanta. Einstein is considered the third founder of quantum theory because he described light as quanta in his theory of the photoelectric effect, for which he won the 1921 Nobel Prize. Quantum numbers. Quantum numbers is the number that tells the address of electron inside an atom. Electrons in an atom are specified by a set of numbers called also a quantum numbers. The four quantum numbers. principal Qn, N, azimuthal, secondary Qn and L, magnetic Qn and Ml, spin Qn and Ms. This is the number, principal Qn number, angular momentum quantum number, magnetic quantum number, spin quantum number, and this is their symbol, N, L for the angular, M for the Ml for the magnetic, and Ms for the spin quantum. And there is the possible values for the principal 1, 2, 3, 4, and so on. For the angular is start for 0, 1, 2, 1, 2, 3, and 2, n is equal to I minus 1. For the magnetic is negative L. It start for negative. And for the spin is positive and negative. We have example here, relationship among values n, L, and M through n is equal to 4.